All right, we're gonna solve multivariable systems using elimination. All right, so here are the steps to solving three variable systems. So typically what we do is we try to eliminate one out of our three variables, and we do that twice so that we have two equations, right? The two equations, I would call them new one, new two, right? New equation number one, new equation number two. And then using those two new equations, after you eliminate one of your variables, you're left with just a regular system of equation in two variables that you guys already know how to solve. All right, and then once you get that, you solve that little mini system, and then you plug in your solutions to that little mini system back into your original equation. Right, so if you guys know in two variables, right, in like two dimensions, we get a little lines, right? So we get a line that might look something like this and a line that looks something like this. And then they intersect at a point, and that point is your solution. All right, in three variables, you have, okay, so here we have an x and a y. In three variables, right, so you might have an x, you might have a y, but you'll also have a z, right? And you're in 3D, right? So I don't know if that looks 3D, but it's like a 3D three-dimensional space, right? So where you might have one line going this way, you'll have another line maybe going that way, and then you'll have another line that meets at the same point, right? So they meet at a singular point, right? And then it'll look something like that. Visually, that's what it would look like. We're not going to have you graph any of these, right? That would be kind of crazy, but just so that you guys understand what our answers represent. Now, in two variables, we had an ordered pair, x comma y. If you have three variables, it's going to be an ordered triple, right? So you need your x and y variables, but you also need a z. So your answer would look something like that. All right, so let's get started. I'll go kind of slow for this one just so that you guys can understand all of the steps that we need to do, right? So there are a lot of steps in these kinds of problems. It's not particularly challenging, it's just a lot of work, right? So I'm gonna label these. I would always start by labeling equations 1, 2, and 3. All right, just because you're gonna notice that you're gonna have a lot of equations written on your paper, so it's good to know what represents what. All right, so now between equations 1, 2, and 3, you want to eliminate one out of your three variables. So you can choose to eliminate x, you can choose to eliminate y, or you can choose to eliminate z. You always want to make it easier for yourself, right? So you can try to eliminate y if you want to, or z if you wanted to, right? You notice that in equation 2, you don't even have a z, so you might want to try that. But if you look at the coefficients, right, if it's not convenient to mess with the coefficients, right, don't do it. It looks like here the easiest thing to do is eliminate x, right? Because with x, I have equations 1 and equation 2, where if you combine those, the x's cancel out immediately. So then I'm going to combine two of my equations, equation 1 and equation 2. All right, so this is going to get you x minus 2y plus 3z equals 19. And then my second equation is negative x plus 3y. I'm going to leave a space for z just so that everything lines up perfectly, equals negative 4. All right, this is 19, this is 9. Sorry about that. All right, and then so your new equation is going to be whatever you get when you combine these two, right? So if you combine these two equations, x minus x goes away, negative 2y plus 3y is y, 3z, nothing combines with 3z, so I'm just going to write y plus 3z equals 9 minus 4 is 5, all right? And then so you get an equation with two variables, right? I'm going to call this new 1, right? So this is my new equation number 1, all right? I'm going to do the same thing using any other two equations to try to cancel out x again, right? If you canceled out x once, you want to try to cancel it out again. All right, so let's do 2 and 3, right? That's another kind of easy one to pick just because the coefficients are already opposite signs, right? You just need to do something to get the coefficients to match, right? So let's do equations 2 and 3. Equation 2 is negative x plus 3y I'll leave a space for z, equals -4. All right, number 3 is 2x minus 5y plus 5z equals 17. All right, and then again, you want to try to eliminate one of your variables. If we did x the first time, you want to do x again. All right, so let's try to eliminate x. Because they already have opposite signs, we just need to multiply one of our two equations by something to get the coefficients to match. Right, in this case, if you multiply everything by 2, then you get your coefficients to match, right? -2x plus 6y is going to equal -8. Right, just multiply everything by 2. And then notice that when you combine, 2x minus 2x cancels out. -5y plus 6y is 1y. And then nothing combines with 5z, so I'm just going to leave it alone. This is going to equal 9. Right, and this gives us a new equation number 2, so I'm going to call this new 2. Right? And then now using these two new equations, right, so that's usually the hardest part of these kinds of problems is figuring out what your two new equations are, right? They could vary depending on what steps you take, right? But either way, regardless of how you do it, you should get two equations with only two variables. So I'm going to use new equation 1. I'll just call it n1. That's y plus 3z equals 5. And then my new equation number 2 is going to be y plus 5z equals 9. Right? And then using these two equations, we have a little mini system, right? So this is our mini system within our bigger system, right? And so we want to try to solve this, right? So treat this as if it exists in its own little universe, right? So treat it as if this is a problem that I gave you in the previous lesson, so section 9.2, right? This is just a regular elimination problem, all right, which we can solve by getting one of our coefficients to be the opposite of the other. So I can try to multiply the first one, so new equation 1 by -1, right? And then that's going to change the sign of everything. I'm just going to write it underneath. We get -y minus 3z equals -5. And then I get y minus y, which cancels out. 5z minus 3z is 2z, and then 2z equals 4. All right, and then 2z equals 4, very simple math. All you have to do is divide by 2. And then so you get z equals 2. All right. And then once you get this one, again, you're still working in your little mini system that you had created. All right. So then with this, I'm just going to plug it into one of my two equations. It doesn't matter which one you do. I'll just plug it into new equation number 1. And that's going to get us a y plus 3 times 2 equals 5. All right. So then I get y plus 6 equals 5. Subtract 6 on both sides, I get y equals -1. All right, so solving this little mini system was fairly simple, right? Again, the hard part is just getting your two equations. And then now, all you have to do to get x is plug in your two answers that we just got. If I just got y equals -1 and z equals 2, I'm just going to plug that into one of my three equations, right? I'm just going to plug it into the first one. All right, so then I get x minus 2 times -1 plus 3 times 2 equals 9. And then I get x plus 2 plus 6 equals 9. I get x plus 8 equals 9. Subtract 8, and then you get x equals 1. All right, and then so your answer as an order triple, again, is going to be x comma y comma z. So it's going to be 1, -1, 2. All right, so again, lots of steps, but this is really as complicated as it gets. I mean, the only other cases that you might see are maybe some no solution cases, but still you just need to know when to look out for that. But otherwise, that's how you do these kinds of problems. All right, let's keep going. Same idea here. I want to try to eliminate one of my three variables. All right, and like before, I'm going to label these 1, 2, and 3. All right, and it looks like the easiest thing to eliminate is going to be the z, right? Just because we already have an opposite sign for z, right? If you look at equations 2 and 3, negative z and plus z are going to cancel out, and then all you have to do is use the opposite sign from equation 1 to eliminate that one, right? And I'll show you what that means after I combine 2 and 3. All right, so let's first combine these two equations. All right, so 2 combined with 3 is going to get you, okay, I'll just rewrite it, 2x plus y minus z equals 2. X plus y plus z equals 2. Right, and then when you go to combine these, you get 3x plus 2y, and then our z's cancel out. And this is going to equal 4. Right, and again, I'll call this new equation 1. Right, I'll just label it n1. All right. And then once we do that, we want to combine another pair of equations, right? So I had said we can do 1 and 2. Right, if we combine equation 1 with equation 2, right, we're going to get 3x plus 9y plus 6z equals 3. The second one is 2x plus y equals, minus z equals 2. Right, and once again, if you eliminated z the first time, you have to eliminate z again. Right, so to eliminate that z, we already have positive and negative. We just want them to have the same number. All right, so I'm going to want to multiply this second equation by a 6. Multiplying by a 6 is going to ensure that we have the exact same number, right, just with an opposite sign. All right, so 6 times that entire second equation is going to give us 12x plus 6y minus 6z equals 12. All right, and then I'm just going to rewrite the first equation right underneath it so that way you guys can see how it combines. All right, once we combine these, 12x plus 3x is going to get us a 15x. 6y plus 9y is 15y. Negative 6z plus 6z cancels out, and then we get that this equals 15. All right, and this is new equation 2. All right, so I can use new 1 and new 2 to have a new mini system, right? So I'm going to have new 1 is 3x plus 2y equals 4. New 2 is going to get us a 15x plus 15y equals 15. All right, and then here we want to try to eliminate one of our variables, right? This is a little mini system that we have within our larger system. All right, so I want to try to eliminate one of our variables. It looks like the easiest one to eliminate is going to be the x's, right? Because 3 and 15, 3 is a multiple of 15. Or I'm sorry, 15 is a multiple of 3. So that means I can multiply this entire equation by 5 to get the same sign. Or you can do negative 5 so that it has the same number but opposite. All right, so if I multiply this entire first equation, this first new equation by negative 5, you get a negative 15x minus 10y equals negative 20. And then when you go to combine these, the x's cancel, and then you're left with 5y equals negative 5. And then very simple, you just want to divide by 5, and you get y equals negative 1. All right, and then so I can plug that back into one of my two equations. It doesn't matter which one. And so we get a 3x plus 2 times negative 1 equals 4. Right, I'm plugging it into the first equation. We end up with a 3x minus 2 equals 4. And then very simple algebra, we can add 2 on both sides, and we get 3x equals 6. Divide by 3, and we get x equals 2. All right, so we already have 2 out of our 3 variables. All right, to find the third, you want to plug these 2 numbers that you just got back into one of your equations. All right, pick whatever looks easier, right? I think equation number 3 looks easiest. All right, less coefficients, less work for us, right? So this is going to be an x plus negative 1 plus 2 equals 2. Right, this one was y, this one was, oh, I did that wrong. Sorry. Okay, so I have x is 2, and we're looking for z. All right, so then I have a 2 plus negative 1, which is a 1, plus z equals 2. Subtract 1 on both sides, and you get z equals 1. And that gives us all three of our variables. So our ordered triple as an x, y, and z. Triple is going to be 2, -1, and 1. And that's our final answer. All right, so again, lots of work, but if you're careful with your work, shouldn't be that bad. Alrighty, let's keep going. So we can solve this one same exact way. Look out for whatever variable looks the easiest to cancel out. In this case, it looks like y is easiest to cancel out because we have a positive y and two negative y. So we can just use that positive y to cancel out the two negatives. All right, so again, just for ease of, so that you guys have an easier time following along, I'll label it 1, 2, and 3. All right, I'll combine equation 1 with equation 2. All right, so this is going to be a 2x plus y plus z equals 9, -x minus y plus z equals 1. All right, like I keep saying, you don't need to use you don't need to use the same variables that I'm using, right? Just use whatever is easiest for you. Cancel out the y's. 2x minus x is x. Z plus z is 2z. 9 plus 1 is 10. All right, so this is going to be new equation 1. I'll call it n1. All right, I'm going to use 1 and 3 now to cancel out a y. All right, so equation 1, equation 3. So it's going to be a 2x plus y plus z equals 9. And then a 3 is going to be a 3x minus y plus z equals 9. Combine these, 2x plus 3x is 5x. The y's cancel, z plus z is 2z equals 18. This is new equation 2. All right, so then I want to solve another system using these two equations. So x plus 2z equals 10. And 5x plus 2z equals 18. Right, using new 2 and new 1. All right, so let's solve this little mini system. It looks like we can most easily cancel out the z, right? They have the same exact coefficients. I just need to make one of them negative. So I'll multiply the top one by -1. Right, that's going to give us a -x minus 2z equals -10. 5x minus x is going to be a 4x. Z's cancel out. 18 minus 10 is going to be 8. Divide both sides by 4, and so we get x equals 2. All right, and now to get z, plug it into one of your two equations. Does not matter which one. I'll plug it into new equation 1. So then it's going to be 2 plus 2z equals 10. Subtract 2 on both sides. I get 2z equals 8. Divide by 2 on both sides, and I get z equals 4. All right, so then that gets us 2 of our 3 variables. To get the last one, plug it into any of our systems. Does not matter which one, I'll plug it into the first. All right, so I know that x is 2, so it's going to be 2 times 2. I don't know what y is, and I know that z is 4. So plug everything in. 2 times 2 is 4. Plus y plus 4 equals 9. 4 plus 4 is 8. So I go to y plus 8 equals 9. Subtracting on both sides, 9 minus 8 is 1. So y is 1. So now I have our 3 variables. Your answer as an ordered triple is going to be 2, 1, and 4. All right. So again, I did this one a little bit faster than the other two, but once you understand the steps, you're able to do it a little bit more efficiently. Okay, let's keep going with examples. Your guys' notes have something a little bit different, so I'm gonna replace it. I want you guys to replace it with, okay, I'll black out that one. But it should read x plus 2y minus 3z equals -1. Okay, that's a 3. All right. Yeah, it should read something like this. But that being said, let's still try to do the same process. So I'll number the equations, 1, 2, 3. And you can pick any variable to cancel out. I'm going to do z this time because I see a positive z and two negatives. So I'm going to combine equation 1 with equation 2. All right, so I get an x minus 3y plus z equals 1, and a 2x minus y minus 2z equals 2. All right, in order to cancel these out, I need the z's to have the same but opposite coefficient, so I'm going to multiply that first equation by 2. And this is going to get us a 2x minus 6y plus 2z equals 2. All right, when you go to combine these, 2x plus 2x is 4x. Negative y minus 6y is negative 7y. Negative 2z plus 2z goes away. And now you just have an equation in two variables. This equals 4. And again, I'm going to call this new equation 1. All right, we can do the same thing with equations 1 and equations 3. Okay, so 1 and 3. 1 is x minus 3y plus z equals 1. And then we're going to do equation 3 this time. So it's going to be an x plus 2y minus 3z equals negative 1. All right, once again, I need the z's to cancel out. So you can multiply by equation number 1 by a number to get the z's to cancel out. It's going to be 3 this time. So we're going to have 3x minus 9y plus 3z equals 3. And you can combine these. X plus 3x is going to get you a 4x. 2y minus 9y is negative 7y. And then your z's cancel out. This is going to equal 2. So this is going to be new equation 2. And you're going to use these two equations to create a new system. So we're going to have a 4x minus 7y equals 4. And then new 2 is going to be 4x minus 7y equals 2. All right, and you might already be able to tell what's going on here, right? But you can always keep going until you see it all the way. If you want to cancel out a variable, you're going to have to multiply one of your equations by negative 1. All right, so I'm just going to do the first one. And if you do that, we end up with a negative 4x plus 7y equals negative 4. All right, and then 4x and 4x cancel, so that becomes a 0. Negative 7y plus 7y also cancels, and 2 minus 4 is going to get you a negative 2. So in the end, we end up with 0 equals negative 2. All right, that is not a true statement, so this equation is going to be a no solution. All right, and then from here, no more work is needed. You don't have to go to plug anything in. There's nothing to plug in. All right, you already get your answer from that. All right, let's try the same thing with this one. This is another one that has a little bit of a typo in your notes. This should read not a 2 at the end, but this should read 1. All right, but anyway, let's do the same thing. I'll number them 1, 2, and 3. All right, we can always cancel out a variable. If you notice in equations 2 and equations 3, they each have 2 variables. All right, but we don't want to use those as our 2 equations because they're not the same variable, right? So you can always keep combining. We can do equation 1 and equation 3, right? That seems like the most obvious choice, right? The x minus x. All right, so if you combine equation 1 with equation 3, right, equation 1 is x plus y minus 3z equals negative 1. Equation 3 is negative x plus 2y equals 1. All right, and then the x minus x cancels out. Y plus 2y is 3y. And then minus 3z, nothing combines with that. And this equals 0. All right, so I'm going to call this new equation 1. And if you notice, we don't need a new equation 2, right? Because our original equation 2 is already in terms of y and z. All right, you can just use that same equation. So I'm just going to combine new equation 1 with equation 2, and that's going to be a y minus z equals 0. All right, and then from here, we can try to get them to have the same coefficients, but opposite, right? So equation 2, I can multiply that by negative 3. and then we end up with a negative 3y plus 3z equals 0. And then I'm going to use new equation 1. It's going to be a 3y minus 3z equals 0. And then when you go to combine these, negative 3y plus 3y is 0. 3z minus 3z is also 0, and then 0 plus 0 is 0. We end up with a 0 equals 0. All right, this does work. All right, that is a true statement, so this is infinitely many solutions. All right, so another case to look out for, but it's another distinction between this and a no solution case. All right, so these are your only special cases that you'll run into. All right, for the sake of the lesson and for the sake of time, I'll stop right here. I'll leave the 2 examples for you guys as an exercise, right? But that covers the main idea of the lesson.